Alright! Hello everyone and welcome back to Millie's Metrics. In the last video we talked about what stats is and the different types of data. Today we're going to be looking at how to visualize all the data with different types of graphs. We'll be talking about bar charts, pie charts, histograms, and scatter plots, and I'll show you some examples that are super easy to follow for each one of them. I will also be using RStudio to illustrate them. This is the first statistical software that I have worked in, and it's super easy to use. You just gotta learn your way around it. Having said that, we can get started now. Okay, so we'll start off with bar charts. These are great for comparing data across different categories. Let's say we want to compare the number of episodes in different Star Trek series like The Next Generation, Voyager, Deep Space Nine, and Discovery. Each series will have a bar, and the height of the bar will show how many episodes it has. Okay, now we will open R and get right into it. So as you can see, we have created two variables, one to store our series and one to store the number of episodes. Then we used the bar plot function to create our bar chart for the Star Trek episode counts. And this was the outcome. As you can see, the x-axis represents the different series and the y-axis shows the number of episodes in each series. And from what we can see here, Next Generation, Voyager, and Deep Space Nine have much higher episode counts than Discovery, which has far fewer episodes. And this gives you a quick comparison between the series lengths. Awesome. Now for pie charts. These are great for when you want to show proportions or percentages. For example, let's see what percentage of fans prefer each Star Trek series. Okay, so here's our output, and as you can see, each slice represents a different series, and the size of each slice corresponds to their percentage. We can see that the Next Gen has the largest slice at 40%, followed by Voyager at 30%, with DS9 and Discovery each having 15%. So this chart is a quick way to see how preferences are distributed among these series. Now let's talk about histograms. These are used for continuous data. Let's say you're comparing the lap times of F1 drivers, because we love F1. A histogram will show us how often lap times fall within certain ranges. And of course, if you know, you know. We missed some. So this is our code. We have used the hist function, and the x-axis represents the lap time ranges, and the y-axis shows how many laps fall into each range. You can see that the most lap times fall into the 90 to 95 seconds range, which is the tallest bar, while the 85 to 90 seconds range has the fewest laps. Stem and leaf plots are pretty easy. They're usually used for smaller datasets, and the first digit represents the stem. In our case, since our values are ranging from the 80s to the 90s, the stem is going to be made out of 8 and 9. Now, the second digit represents the leaf, and this is the rest of the digits forming the numbers. It is super easy to illustrate in R as well. We've just got to use the stem function. Lastly, we'll look into relative frequency histograms. This is like a normal histogram that we have talked about earlier, but instead of showing the raw count, it shows the percentage of the data that falls into each range. Let's take the same lap times and make a relative frequency histogram. So this is our relative frequency histogram, and it shows the percentage or proportion of data that falls into each range rather than the raw count of data points. The y-axis shows the percentage, which is the relative frequency, which is the frequency over the number of whatever we have. On the x-axis, we can see the different ranges. We use relative frequency histograms to help us compare data even if the data sets are different sizes. It normalizes the data, and this is a keyword, because it makes it easier to understand. For example, in lap times, in F1, a relative frequency histogram shows you what percentage of laps fall within a certain time range, not just how many laps. This helps you compare distributions across races or datasets. You might be wondering, what is up with this curve? Why does it appear here? Well, when you add a density curve, like in a relative frequency histogram, it smooths out data, showing the overall distribution. It appears because we're looking at the probability distribution of the data, showing us where most data points cluster. Now, Maxwell says it's quiz time! Let's see. Which types of graphs would you use to visualize the following? As usual, you can take a minute and write your answers in the comment section. You will also find a comment that's pinned with the answers. And that's it for today! Now you know how to visualize data. And in the next video, we will dive into calculations like averages and standard deviation. So stay tuned. Thanks for watching, and I'll see you in the next one. Bye bye. We're comparing the lap times of F1 drivers because we love F1. A histogram will show us how often lap times fall within certain ranges. And of course, if you know, you know. We wish them. So this is